Hello and Assalamu alaikum everyone. I'm Dr. Afzal Badsha and today we will discuss what is big data, what are the applications of the big data, the technologies which are used to process the big data, and definitely the challenges which are associated with the big data. Big data is everywhere nowadays. There is no such a field or domain where the big data is not generated or not processed. It is, we can say, the integral part of every field now. It is just like a computer that nowadays computer or ICT are part of every field or every department or every organization. In such a manner, we can say that nowadays the big data is the part of every field, every domain. I'll give you one example related to the big data that this shows the importance of the big data, and this is the code which is nowadays particularly used for the big data to demonstrate the importance of the big data. In earlier days, the people who were connected to the gold business, so they were earning well, they were well settled, they were wealthy, they were doing very good in their life. Similarly, later on, when the business of coal started, so the people who were connected to the coal business, they were similarly earning well, they were well settled. This was the reason that the coal was usually called a black gold, because this business was similar to the gold business. The people were earning the same, the people was the people's status was the same. And similarly, nowadays, the big data is called a gold, because the big data, why the big data is called a gold? Because people, organizations, companies get insight from the big data, from the millions and billions of transactions, and on behalf of these transactions, on behalf of these insights, they take some types of decisions, and according to this decision, definitely their businesses grows. So we can say that the big data is the gold of this era, this modern life. This clearly shows the importance of the big data. The next thing is that how we can define the big data. A couple of years ago, I was in interview and I was asked about the big data, that how we can define the big data in terms of threshold or in terms of any limits. They actually asked me that how we will say that after crossing any particular threshold that this is now a big data, and before that threshold we will say that this is not a big data. So I have defined the data as we usually defined, and yeah, I tried to convince the panelists, but they were not satisfied. I was confused that I'm a big data researcher. I talk on big data, I write on big data, but why I'm not able to satisfy them? Why I hadn't read about the size on any particular threshold or any particular limitation related to the big data. So one of the panelists was so kind. He asked me that, Afzal, do you know about the three V's? Exactly, three V's are very popular. So I defined the data in terms of these three V's. So the panelist told me that, Afzal, this is a correct definition of the big data according to which we define the big data. So what are these three V's? These three V's are volume, velocity, and variety. So what is the volume? Volume means that the data must be big in volume, must be big in quantity. So any person who is not related to big data terminologies or who are new to the big data or computer science, so when they listen about the big data, the terminologies they listen, the thing which come in their mind is that the data which is big in volume, which is big in a quantity. So this volume or this we exactly show this, that this data must be big in the volume. The second thing is the velocity. Why do we go towards the velocity? Because only volume is not going to define the big data. If there is any data which is static, which is not continuously generated, it is in a single structure, then we can't say that this is a big data. The second thing is the velocity. Velocity says that this data is continuously generating. For example, let me take you the example of the Facebook or the YouTube, etc. In a Facebook or YouTube, you can see that millions and billions of people are connected there. They upload, they stream videos, photos, etc. every day, and every day millions videos are updated there. So we can say that this data is continuously generating, this data is continuously updated there. So the second we satisfy there, that this data is big in volume, and secondly, this data is continuously generating with a particular speed, with a particular velocity. The third one is variety of the data, which define that this data is not in any particular type, any particular variety. We can't say that this data is in a relational model. This data may be relational, this data may be, as we can say, this may be data may be structure, unstructured or semi-structured data. Let me take you once again towards the social media. People upload photos, they upload any type of tags, they upload tables, they upload videos or photos, etc. Or if you take an example of vehicular big data, the data generated by the autonomous vehicles. So different type of sensors are there, lidar, radar, sonar, etc. And different type of high definition cameras are there. So data generated by these vehicles are also, we can say, unstructured data. Or you can take an example of the forecast system. Millions of sensors are there around the world. The geoinformatics satellites are there, they generate high definition videos, photos, they generate very high definition maps, etc. So we can say that this data is unstructured data. This data is also big in volume, and this data is also continuously generating. So all these example, either this is a social media, either this is a vehicular big data, or the data generated for the forecast system, all this data fulfill the conditions of these three volumes, these three V's, that this data is big in volume, this data is continuous generating with a particular any velocity. Velocity means that this is continuously generating. And the third one is that the data is in a different variety. This is also in structure, unstructured, or semi-structured data. So these are the three ways which are basically used to define the big data. And these three ways were introduced in 2001 or 2002. But later on in 2010, two other V's were also added. These other two V's are veracity and value, which actually define the veracity of the data, the value, the importance of the big data. But as a student of the big data, as a teacher of the big data, or a researcher of the big data, I'll suggest the earlier three V's, which is volume, velocity, and variety. These three V's perfectly define the big data. It perfectly distinguish the big data and other data. So I will suggest to go with these three V's. The next thing which come in our mind, that how this big data is generated, who is generating this big data. About 50 million or 50 billion or 20 billion devices are connected to the internet, and it is expected that these devices will reach up to 50 billion by 2030. So somewhere I read that currently 30 billion devices are connected, and by 2030 this will reach up to 75 billion devices. Actually, I read this on the statistics.com, which is very popular website for different type of statistics. So you can imagine that there are 7.5 billion populations around the world, and the devices which are going to connect it is 50 billion or 75 billion by 2030. So this will generate a flood of data. This will generate a tsunami of big data. which type of these devices are actually we are using the mobile phone currently. If you are watching this video on any mobile phone, then you can imagine that how powerful your mobile phone is, what type of sophisticated cameras it is using. It can record a high definition video, a high definition photos, similarly audio, etc. And similarly the streaming application allow us to stream this high definition videos to the network. Similarly, the sensors around the world, the sensor installed in the smart cities, the smart sensor used by the forecast system, the sensor used by geo-information system, the sensor used by autonomous vehicles. So we can say that there are massive devices which generate a tsunami of big data. So definitely, if such a big data is used, definitely we will need some sort of technologies to process this data. Let me give you one example. If there is a any you are using any mobile phone, or you are using any laptop, and you want to edit some type of videos which are high definition video, and sometimes your computer or your mobile phone get stuck, get hang, because the computer capacity are not able to process this big data. If the system is not able to process a single application data, then the data generated by billions of devices, how this data will be handled? Definitely we will need some sort of technologies. There may be parallel processing, distributed processing, so they have their own framework. We will need some sort of databases, we will need some sort of programming language, etc. Let me give you an example that how this data is actually handled on the computer, on the clouds. If there is a chef in the kitchen, and he is preparing something, he is a single person, he is responsible for chopping, he is responsible for sauce, he is responsible for dishwashing, and he is also monitoring the dishes too. So this will take a long time to prepare a dish, but if we place there 4 to 5 chefs, definitely the work will go in parallel. One will chop the vegetables, one will prepare the sauces, one will wash the dishes, and one will monitor the cooking, etc. So definitely the same techniques of parallel and distributed processing techniques are used to process this big data. The parallel processing techniques are also used in our system too, because we use more than one processor, we use different type of cores, but it is not scalable. We can't scale our laptops or computer resources from any particular threshold. But because in a system, when we upgrade our scale, this is actually horizontal scaling. So horizontal scaling is limited. We can go to a certain limits, and after that we would not be able to scale that. But when we talk about clouds, when we talk about distributed processing, there we use the horizontal scaling. And with the horizontal scaling, it is its capability that it scale according to the incoming request, according to the incoming data. So the system, the technologies which are used, the databases which are used, they create one ecosystem, as the ecosystem which we have in our world, that plants generate oxygen, and the animals generate carbon dioxide, so they consume their products, and etc, etc. So the technologies which are used in the big data ecosystem, that there may be certain type of technologies, for example parallel or distributed processing techniques. There may be some type of analytical visualization techniques or business intelligence techniques. There may be cloud server providers, because when we talk about big data, it is sure that it needs certain type of expertise, it needs a special type of hardware and software. So the ordinary organizations or a single individual will not be able to start their own cloud. This will need some sort of cloud providers enterprise level of cloud providers. NoSQL databases will be needed. When we were defining the big data and we were talking about the three ways, then there was one way: variety of data. Variety of data means that this data may be structured, unstructured, or semi-structured data. So we can't store the unstructured data in a relational databases, in a SQL databases, as we use the tabular format, the relational format for structured data. So definitely we will need the NoSQL databases. We will discuss what are the NoSQL databases, what are the technologies which are used to process the big data later in this video, but I'm just giving you a hint that what is actually the ecosystem of the big data. Similarly, it is not an easy that we just say that we do the parallel processing and the distributed processing. We have to instruct the system, we have to instruct the processor that how the incoming request will be handled. For that we need a special type of languages, a special type of tools to program the computers, to program the servers or the CPUs, that how to handle data in parallel or in distributed processing. What the data, how the big data create a cycle, or how this big data is traveled toward the cloud, and how this is used or processed there. The devices, as we discussed here, the 15, 20 or 30 billion devices, they generate the data. And then network technologies, this may be landline, 3G, 4G or 5G, this data is migrated toward the cloud. And on the cloud, certain type of ML algorithm or models are used to get some insight from this data, and then these insights are used for certain type of decisions. Not only for the decision or the business decision, this data is also used later on for number of the purposes. When we were discussing the ecosystem, then we just touched the what are the technologies which are used to process or handle the big data. So in the next couple of minutes we will discuss that what are the technologies which are used to process the big data, store or retrieve the big data. So we must know about the parallel processing and distributed processing. Parallel processing means that there is more than one processor. For example, there are 100 processors. Then the master processor will distribute the workload on other 99 processors. This is called a parallel processor. It is exactly the same example of the one chef in the kitchen and 5 chefs in the kitchen which work in parallel to minimize the total time. Distributed computing means that instead of processing the data on single server or a single place, we can distribute the workload regionally on different servers. So the technology which is used for that one is the Hadoop. Hadoop is very popularly, we should say that it was popularly used after 2006. Hadoop actually worked that it gets the master node. It is just like a master and worker architecture, the client and server architecture. The master get the workload, the request from the users, and it further distribute this workloads on the worker on the other nodes. So when the work is distributed for processing, this is called mapping. And when this work done, which is processed by these worker nodes, this is get back and integrated, this is called reduce. So the Hadoop use map and reduce function to process the big data. In 2009, the Spark was introduced, Apache Spark. Spark is popular for its faster speed because it use in memory processing, and it is about 200 times faster than Hadoop. So in 2014, this was bought by the Apache, and nowadays this is popularly used, widely used by the cloud providers. Apache is a name. Apache, any person who is a student of the big data must know about the Apache. That Apache work on the tool for the big data processing, storing, and retrieving, etc. There are a number of applications of big data which are popularly used by the companies, by the providers nowadays. Hadoop, Apache Spark, which is distributed processing techniques. The next thing is NoSQL databases. When we were defining the big data and we were discussing the three V's, then the last V was related to the unstructured variety of data. So when there is a variety of data, this means that we are not going to store this on a relational or any table of format. We were not able to use the SQL databases which we usually use, such like Excel, SQLs, any other sort of the databases which are actually used to store the data. We will need some sort of databases, NoSQL databases, which can store the variety of data, the unstructured data. So the NoSQL databases, Apache Spark, use Cassandra, which is also popularly used. MongoDB is popularly used, and I also work on the MongoDB. All these databases are used to store big data, unstructured data particularly. We will need data warehousing. Any individual, any organization who is starting their data-driven applications, they can't create or organize their cloud server in their initial days. So they depend on some sort of the cloud providers. They get the services of warehouses. So warehouses are the technologies to store and retrieve the big data. Machine learning and artificial intelligence is particularly important in big data, because big data means that there is a massive data, and if we are saying that the big data is a goal, then there is a reason behind that. We are utilizing this data for any particular insight, for the decisions, or any other positive results. So definitely for that we will use any machine language, a machine learning algorithm. We will use any type of ML model to get these insights from the data. So with the big data, machine learning technology is also important. Data integration tools are used to integrate the data, as the big data is usually processed on a distributed system using the Hadoop or using the Apache. We will need some sort of the technologies to integrate this big data. The next thing is streaming tools. Streaming is nowadays very popular. We use that to talk to our friends, our families. We use that for the online streaming. The channels, the TV channels use this for the online streaming, etc. So streaming is becoming very popular nowadays, because all of the channels, instead of using the traditional way of TV channels and the cables and the satellites, etc., all of them are now converting toward the internet, toward the cloud. So all of them need any sort of streaming application. Apache Spark uses Kafka, and there are some other few applications too, which is particularly used for the streaming application to stream the data. Data visualization means that the data, to present the data in a particular graphs, or to visualize the data in a graphical format. If, for example, there is an organization having millions of transaction data, so from these millions of transaction data, no one would be able to get insight, because this is not a human capability to get insight, some sort of decision from such like a big data. So what we can do, we put this data in the form of graphs to represent, for example, the company sales, the best selling product, the worst selling product, the regional best selling product, and similarly the seasonal good selling product. And from these insights, they can reach to any decision which they can make related to their business, related to their products, etc. So data visualizations are also very important for for big data analysis. The next thing is the blockchain technology. Where is the data? There is a security threat. There is a cyber threat chances. So we use a data security techniques. Blockchain technology, which is merging technology to protect the data. So blockchain is massively used to protect the data on cloud, and nowadays you also listen about the digital currencies, and for digital currencies, which is also a big data, for that the blockchain technology is used to protect this data. Edge computing is also a part of these big data technologies, because if there are, for example, 50 billion devices or 30 billion devices, they generate a massive data, and this massive data is not needed on the cloud, particularly in peak hours. So we can use some type of edge computing where this data is processed. Let me give you an example of an organization. If this organization have 100 HD cameras for their security purposes, so this data is not needed at the cloud every time. They can migrate this data to the cloud in any of peak hours, or if there is any type of detection, movement detection, or if there is any type of warning detection. So after that, this data is needed on the cloud. So why we are going to stream this data 724 to the cloud, particularly in the peak hours? This congest the network, this make the network unreliable, particularly for the healthcare system, for the vehicular data, because these applications, these real-time applications need a very real-time response, and this big data which is not needed on the cloud create make the network unreliable for such like applications. So this is the reason we use an edge computing for such like data. Cloud computing, without there is no options of big data to process or store the big data. Cloud is not a technology, but it is a combination of technology to process, store the big data, and also to utilize these services just like a utility, as we usually use the utilities of gas, water, electricity, and we pay according to their usage. So for big data, for such like resources, we need the cloud providers also. Communication technology, because without the communication technology, we can't migrate or transfer this data towards the cloud, because the cloud servers is the ultimate destination of this data. So all the communication technology, either these are the landlines, these are the 3G, 4G, or 5G, these are the technologies to transfer this data toward the cloud, or towards the cloud server. So these were the basic technologies which are used to process or store data. Let's revise. Before going to discuss the big data technology, you must know that what is parallel processing and what is distributed processing. Hadoop, Apache Spark, NoSQL databases, data warehousing, machine learning, data integration tools, streaming tools, data visualization tool, blockchain technology, edge computing, cloud computing, and communication technologies. All these are the technologies, or the combination of the technologies which are used to process or store big data on the clouds. Let's go towards the issues or challenges or the concerns which are related to the big data. Definitely, if the big data is so important, it is widely used, every department or every field is generating the big data and utilizing the big data, then definitely there will be some sort of issues, challenges, and are some sort of people concerns related to big data. So in the next couple of minutes we will discuss these concerns, that what are the basic or potential concerns related to big data. The first thing is the network congestion. Network congestion means that devices, the flood of the devices are generating a data, and this congests the network, particularly in peak hours. And due to these congestions, the network is not reliable. The real-time application will not be able to use that. In the evening time, you can see, because this is a peak hour time, everyone use their devices. People stream the data on their television from their prime shows. So in such timing, usually we feel that our internet is not correctly working. Sometimes we feel that we can't talk to our friends or family on the streaming application. Why? Because every person is using the internet, so all the data is generated by every devices, so this congests the network congestion means the network unreliability, which means that the real-time application, the time constrained application, the healthcare application, for example, the autonomous vehicles applications, they would not be able to trust the network. They would not be able to transfer the data, their data on such a network. So definitely we will need to minimize the data towards the clouds, towards the public network, to make the network reliable for every person. Similarly, as we saw that when we open an application, any data-driven application on our system, then our system get hanged. If we are processing millions and billions of transactions on the cloud, definitely we will need special hardware, special software, and to handle these hardware and software, we will need some technology expert people. So the people who are new to the cloud are organizations who are starting their own business. Initially, they will not be able to afford these technologies, the hardware and software technologies, and similarly they will not be able to hire the services of these experts. So this is also resistance toward the cloud, that with such a high demand of software, hardware, and technology expert, this is not an easy task to start your own cloud or your own distributed system. You have to depend on the cloud providers. And when you depend on the cloud providers, we can't assure that our data is a private and there is no security from this data. And sometimes we also see on the social media that some sort of photos, some sort of private messages, videos go viral. Such like a privacy issues arises, and similarly it also create a security issues too, because anyone can access to your big data, to your personal data. Let me give you an example. In 2014, in Pakistan, the organization were notified to install cameras in the institution. There was some certain type of attacks on the school, so this decision was taken. So all the institutions, the cameras were installed in all the institutions, all the school, colleges, and universities, and all this data was integrated to a central hub of the police station. So they were monitoring the system from this central hub. But the issue was that they were linked with a single link, and there was a one simple password which was issued to every organization. And this password can easily be misused by any type of third personality. So the devices or the cameras which was installed to protect the children, to protect the student, to protect the organization, may be used in a wrong format, maybe may challenge the security, because if the terrorist, if they get the password of these cameras, they can easily monitor you, they can easily decide the timing, they can easily do their work as they need. But particularly, but why did we install the cameras? We installed that for the security, but they are utilized to unsecure the lives. With the big data, biases decisions are there because the machine learning algorithm, the artificial intelligence algorithm may get biased. They get some sort of wrong parameters. They give some sort of wrong insights, and on behalf of these insights, some unpopular, unlawful decision may be made. This data is also misused, as I earlier discussed, that we usually see on the social media, in the smart houses, the devices data may be misused. The we can say the security purposes data, the cameras data may be misused. Or similarly, when we visit hospitals or when we visit any other organization, our data is stored there. So sometimes we see that our data is misused. Another popular issue with the big data is with the connectivity of the internet is the cyber laws. For example, you are in a one country and you are writing something, any post, or you are writing any type of social media message. This is legal. This was a legal message in a one country, but you, when you travel to any other country, and there may be any type of different laws, and according to these laws, this the post which you have made, the blog which you have written, or the video which you have uploaded, this may be a crime. So this create a very ambiguous situation, untrusted situation, that the action which is, this is a global village. The world is connected just like a global village. So if the world is global village, the people are connected just like a village, then there must be uh, unique rules. There is no chance and no space for such rules that one thing is a crime in one country and it is not a crime in a second country. So such like situation or such like issues may arise from the big data. The next thing is doubted accuracy. All the data which is uploaded on the cloud, on the internet, this data, we can't say that this data may be accurate. We can't trust this data. The people who are writing on the social media, the channels who are uploading their data on the TV or YouTube channels, and similarly we also can say the data which are uploaded by the sensors, because the sensor also gets some type of issues. So we can't trust this data. This data may be corrupted, this data may be attacked, so we can't trust on this data too. So I'm going to revise that what are the potential issues or potential challenges with the big data, and which we discussed here. These are the network congestion, because the big data will congest the network. Special hardware, special software are required to process this data. And similarly, when we need, if we need a special hardware and software, we will need some sort of technical expert to handle this software and hardware. Similarly, privacy and security issues are there. These are very hot topic nowadays with the big data, to discuss the privacy and security issues. And biased decisions are there, because the ML models, the AI, can biasly treat some data, or they can biasly handle some of the features, and we can make some unlawful or unpopular decision. Data is misused. Different cyber laws are there. Every country has their own laws, so there is no uniqueness in the law. Instead of, this is a global village, but there is no unique law for this cyber world. And the next thing is the data accuracy, that we can't, the data which is uploaded on the cloud on these or on these platforms. So these were the challenges, these were the potential concerns related to the big data. Now let's go towards the big data application. Though big data is everywhere, every domain is using the big data, there is no such like domain or organizations which don't generate big data or don't use the big data. the figure or the list which you are seeing on the screen, I just categorized this from the literature for one of my paper related to the big data, but this is not exactly showing that only these are the fields where we are using the big data. I just categorized that the most popular fields are the most popular domains where the big data is used. So in the list you can see that we were discussed in detail everyone, but list check the list first. The first one is the smart cities, that we use the data in the smart cities. We use this big data in education for number of purposes. Media entertainment is a top generator of big data. Climate and earth science use the big data for different type of predictions, a warning system, in supply chain, in transport, in vehicles, autonomous vehicles. We use this big data. They also generate very big data. Marketing and advertisement, we can say that marketing and advertisement is a hot place for big data. As you can see that when you use YouTube recommend the videos according to your choices, or sometime when you search anything on the browser, then when you open any website, then you can see that such related advertisement are shown here. So we can say that marketing advertisement hotly use the big data technologies. Big data is used in industry. This is the 4.0 revolution. So big data is used by the industry to automate their industry, make some decision related to the productions or logistic decision. Cyber security and similarly healthcare is also using popularly the big data. So let's start from the healthcare, that how healthcare is using the big data. Healthcare, as you can see that there is a data of the patients, there is a data of a certain type of diseases. This data is generated, and according to this data, as some doctors are using the AI models, they are using this big data, and according to these diseases data, some decisions are made, some decisions are taken to recognize any disease or to diagnose any person. We usually discuss that we try to take our patient to any experienced doctor. Experienced doctor means that he has checked more patient, he has more records of patient, more history of patients in his mind. So according to this history, according to these experiences, he can make a good decision, he can make a correct decision, or he can diagnose the patient or disease very well. So what about the big data? If big data means that the data around the world is present related to the patient or the diseases. So any new doctor use any type of machine learning algorithm or any machine learning models to diagnose any person. So this is revolutionizing the healthcare unit. Similarly, instead of visiting the doctor, we can get online appointed the telehealth, through the telehealth, and we can consult the doctors there. So this is saving our time, this is saving our cost, etc. So we can see that the big data is revolutionizing the health in the form of diagnosis, in the form of telehealth, in the form of the pharmacy, because the pharmacy have their own records, and according to these records, because they are keeping the record that how the any medicines have effect on the patient, the positive and negative effects, and these data are then further used to improve their products. Logistic also use generate a big data. The logistic and transport. This can be different categories for logistic, transport, and vehicles big data. But I integrate all them in a one snapshot. Vehicles generate a big data. autonomous vehicles have a number of sensors. They have lidar, radar, sonar. They have high definition cameras. So a very big data is generated. It is said that 4 GB data is generated every second. These vehicles can generate 1 terabyte of data every day. So this is a very big data. This data is not only used to navigate the vehicle on the road, but this is also used to train other algorithm, to train other machine learning algorithm, to train the other vehicles too. Similarly, in the transport, the big data is used. For example, you are going to hire any Uber, you are going to hire cream, etc. So these applications use the big data to calculate the cost, to calculate the prices, or to navigate the route. And in the logistic, we can say that when we dispatch anything by any company, we get any link, we get any password, and through that we can navigate that where our dispatch is, when will it be delivery. It also work on the last mile mileage cost. So this is also revolutionizing the logistic, the transport, and also the data generated by the vehicles, the autonomous vehicles. Marketing is very popular because we came across every day with the use of the big data in the marketing. When you open your YouTube or Facebook, then you get a similar post or the post in which you are interested. Why you are getting the related post or the related content? Because these applications have your data, and according to your choices, according to your search history, they suggest the similar type of content, or these applications shows the relevant type of advertisement. You have searched anything once on the Chrome or on any type of browser. When you open any website, then the related advertisement are shown here. Why? Because the companies use your data to show you the advertisement. This data, the big data, is used by the companies to reach the real customer, to the interested customer. So this is a big market, not in academia but also in the market too, that this data is used to reach the customer, to advertise, for marketing, to analyze the web. And similarly, this data is also used to further research, uh, and similarly we use this for the sales and revenue, etc. Smart cities are very popular nowadays. Smart cities means that everything in the smart cities are smart. The transport is smartly managed. The educations are smart. The homes are smart. The appliances, the electrical appliances used in the houses are smart. The security is smartly managed. And similarly, the government manage the cities smartly. There is no need to visit the offices. We can interact with the government or request to the government by any applications, by any website. So all this generate a very big data. This data, the smart cities not only generate a big data, but this data is also used by the smart cities to make the cities more smarter, to make transparent decisions, and to increase the capabilities. So we can say that this is in the smart cities, data is generated and used by the smart buildings, smart transport, smart government, smart security. This data is further used for research and educations, and similarly for sustainability. Media, or media means the media or the social media. So these are the massive generator of big data. They produce a very big data. You can see on the social media, you can see on the YouTube or the Facebook that millions of videos are uploaded there, or there are millions of channel who are recording the programs, or they are on airing these programs. So how these programs are made? Web analytics are used to reach to the customer that what type of content they like, what type of programs they like, in which area they like these programs, what is the particular time on which they watch such like content. So for that, this so the media is not only generating a big data, this is also a big user for the big data for certain sort of decisions. So we can say that big data is used for content productions, web analysis, archive, social media and streaming, research and education, and similarly monetizing the big data. Cybersecurity is also a part, is also a user of the big data. Where is the big data, there is a security concerns, there are concerns of a cyber attack. So definitely we will use the cyber security techniques, and we will use the previous data to train our algorithm, to train our machine learning algorithm for the cyber security. So to detect the threat, to make the threat detection more intelligence, we will need some sort of data, and this data will train this machine learning algorithm for the cloud security, for the network security, definitely for edge and IoT security, research and education. This data is also used for research and education, and also to protect some sort of application against the cyber threats. Earth science. Earth science means that monitoring the earth for different type of forecast, for different type of threat detections, or for warning. For example, we use the warning system for the floods, for the rains, landslide, etc., for the volcanoes, for the tsunami, etc. So there are millions of sensors around the world, which are monitoring the world, which are monitoring the environment. We have geo information system, we have geo information satellites there. They create a very big data in sort of the HD mapping, high definition videos, high definition photos, etc. So this system is generating a very big data, and similarly this data is used for number of options. They are used for forecasting, they are used for threat detection, they are used for emergency warning system, etc. So we can summarize that it is used for climate prediction, geospatial analysis and the mapping, oceanography, marine science, disaster prediction and warning system. This is used for glaciers, polar studies, and similarly this is used for atmospheric system. Education system also heavily depend on the big data, particularly after the COVID-19. Uh, when after that, the people, instead of visiting the universities or instead of visiting different type of institutions, they get part on the MOOCs, and from there they get their degrees or their certificates, and the teachers record their data, record their lectures online, and they take their lectures online. So a big data is generated, and this big data is also further used, for example, in the classroom. A high definition camera can detect the students engagement in the class. They can detect that which methodology can improve their performance. So so we can say that the education sector is also using the big data in a massive way. For example, personalized learning, for MOOCs, for academics, for web analytics, similarly for pedagogy or assessment. And further, this data is used for further research and for further education. This is the fourth industry. Fourth industry means that the industry is using certain types of sensor. They are using IoT devices, and these devices generate a big data. The devices generated data is used to further train these algorithms, or to control the production. This depends the production, before going toward the productions, the market is analyzed through the big data, through the machine learning algorithms. The logistics systems are checked through the big data or the machine learning algorithms. So according to that, the production decisions are made, that which product should be made and which product should be postponed. And similarly, they decide the routes to dispatch the products towards the market. So this was a brief introductions towards the big data, its applications, technologies, and what are the challenges with the big data. So let's revise the lecture. That first we cover that what is the big data, and we cover the definition of the big data with the three V's: volume, velocity, and variety. Then we discuss the devices, the 15, 20, or 30 billion devices which are connected or being connected to the internet, and the data which are generated by these big devices. And similarly, we discuss the ecosystem, the technologies, the machine learning algorithms, the databases, the cloud providers, the languages, the development tools which are used to process the big data, to store the big data, or to train or program these applications. So these create just like an ecosystem. And similarly, we discussed the data processing, how data is generated, how this is transferred to the cloud, and how the algorithms are applied to get some certain type of decisions, or certain type of insights are taken. And similarly, then we discuss the technologies which are used for the big data. For example, the parallel processing, distributed processing, Hadoop, Spark, NoSQL databases, data warehousing, machine learning, data integration tools, streaming tools, data visualization, blockchain technologies, edge computing, cloud computing, and communication technologies. Similarly, we discuss the potential concerns which are with the big data. For example, the network congestion, special hardware or software need, the dependency on the tech expert, and privacy and security issues, biasness in decision of features, misuse of the big data, and similarly, different cyber laws are doubted accuracies of the data. After that, we discuss the applications of big data, and the popular applications at the popular domain where big data are used are the smart cities, education, media and entertainment, climate and earth science, supply chain and transport, marketing and advertisement, industry, cybersecurity, and healthcare, etc. So we covered in very detail about the big data, and how hopefully you got a lot from this video. Thank you so much for watching.